Hello everyone, let's continue by adding functionality to the camera to follow the player and rotation. So let's start by open up the game settings data script to add a couple of several variables for the camera settings. So let's create a new class, camera settings. Let's make a public float camera look speed, public float camera pivot speed, public float camera smooth time, public float minimum pivot angle, and public float maximum pivot angle. Let's make this class serializable so it can be displayed in the inspector, and add a property here. So header camera settings. Let's add a space as well. And public camera settings, camera config. Minimize Visual Studio to let Unity compile these changes, and let's move on. Now we need to actually set up the values for these variables that we created. So let's go to our settings folder and open up the scriptable object. So we have this new section, camera settings, and let's add camera look speed. Let me just move this to 2, camera pivot speed to 2, the smooth time let's add 0.3, the minimum pivot angle let's add -25, and the maximum to 45. That's it. Save everything and let's move on. Alright, the next step is going to be to create components to hold this data that we want to change on runtime. So let's go to the game, sources, components, game folder, and from here let's create an Entitas component, and let's call it camera look speed component. Let's create another one, Entitas component camera pivot speed component, and let's create the last one. Will be another component called camera smooth time component. So once Unity compiles, let's start by open the camera look speed component in Visual Studio, and let's fill this up. So we want this to be in the game context, but also we want it to be unique, and we are going to hold a float type of variable here. So let's do this float, and let's add a comment. So this is going to how fast the camera moves or follows the player. Local player. Alright, let's go now to the pivot speed. So again, we want this to be in the game context, but also to be unique. And this is going to hold a float variable. And this component is going to handle how fast the camera rotates. You need to compile. And lastly, let's check it out, the camera smooth time component. This also will be into the game and unique context. And let's create float value. How smooth the camera moves towards the player, the local player. So again, before we forget, since we created 3 new components, we need to generate the wrapper for those by going into the tools, generate or Shift Ctrl G. And this is going to create the wrappers for us. Now let's start building the systems. For the systems, let's start by creating the camera follow target system. So let's move into our systems game folder, right click and create Entitas, and let's this is going to be an execute system because it needs to run on each frame, and let's call it camera follow target system. Let's open up in Visual Studio, and here we need a using statement for Unity Engine. I execute system, and also we want it to be I initialize system. For the context, we are going to change this one to game context, and let's rename also the variable. And in the constructor, we can change the list of context to just retrieve the game context. Alongside the game context, we also want to hold a variable for the transform of the camera. Let's make this one read-only as well. And we also want to store or retrieve the settings that we created in the first part of the video. So settings context. Okay, in the constructor we want to also pass or retrieve the transform from the camera. So let's call it transform, the camera transform, and let's assign that to our variable. And let's also retrieve the settings context from the list of context. Since we are going to use this system to follow the local player, which is our target, we need also to store that vector, that transform as a local variable. So transform target transform, and the direction camera follow velocity. And let's initialize to 0. Now the initialize system is complaining because we need actually to implement that. So let's create a public void initialize. The errors goes away, and the initialize, again, remember this is like using the awake or the start Unity methods. So in here we want to get target transform, so retrieve from the game context the local player entity. From the local player entity we need the game view, which is a component that stores the transform, and from here we retrieve the transform. Now from our game context we want to initialize the camera smooth time. This is the component we created earlier. We want to initialize it with the settings, with the value from the settings file. So let's create settings context, game settings, retrieve the scriptable object here, game settings data, camera config, camera smooth time. Now into the logic. So if from the game context this is a local player, we want just to execute this system for the local player, not the proxies. So vector3, let's create target position variable. It's going to be a vector3 smooth dump, camera transform position, target transform position, and we pass as a reference the camera follow velocity to fill this up. Again from the game context, camera smooth time, the actual value. And lastly we change the position of the camera transform to the target position. That's it. So let me close this one, minimize Visual Studio, and let Unity compile. So now that we have our camera follow target, we want to add this system to the scene. So we have here in the mono behaviors, we have this sandbox system mono behavior. So let's open up this one and let's create a couple of variables. So first of all, we want to store the camera root. So let's create a private transform camera root, and let's create a private transform camera pivot. We have created this system, physics systems, but we want the camera to follow the local player in the fixed update just right after he moves. So remember, since we are using rigid body, we are moving the player in the fixed update. So we want the camera to move right after the player's moves. So let's create a dedicated system for that. So let's make a private systems late fixed update systems. In our awake, let's add our new system, late fixed update systems, new feature, let's call it late systems. And after the rotate player system, we create this late fixed update systems, add new camera follow target system. We pass the share context, and also we pass the transfer from the camera root, which is expected in the constructor. So far so good. So in the start, as always, let's copy this late update systems and let's initialize, call the initialize method. We pass the update, and in the fixed update, remember we want the execute to be performed right after the movement of the character. So let's execute here and let's run the cleanup to remove unused resources. Alright, now it's time to create our camera root and camera pivot in the scene, so let's move to that one. Let's jump into the scenes folder and open up the Sandbox scene, and from here we have this scene game object and we have the main camera. So what we want to do here is create an empty game object, and let's rename it to camera root, and let's create another empty game object as a child of the camera root, and let's call it camera pivot. And now let's drag the camera, the main camera, as a child of the camera pivot, like that. The next thing we want to do is to zero out the transform of the camera, and let's add a -4 in the Z axis, and let's check camera root is okay to be all 0, and camera pivot, let's add a 2 in the Y axis. Save the scene. Now let's go to the systems game object, where we have this the script that we just modify and assign in this vector corresponding elements, camera root and camera pivot. Let's save again, and we can try now, we can test it out. So let's go to the bootstrap scene and hit play. Because we don't have any reference in the scene to track the movement of the camera is following the player, we only have this vector. So let's split the sim and game view so we can actually see the movement of the camera being following the player. Hit play. So we are here, and you can see the camera is moving and following the player. If we go into the sandbox and we have the late systems, this is the system with the camera follow target, and it's been executed properly. So if we just disable the component, you will see that the camera no longer follows the player. So this is working as intended. Now let's move on to add rotation logic to the camera. So we want to create a camera rotate system, and we want again to be an execute system with initialization. So let's move to the systems game folder, right click, create, Entitas, execute system, and let's call it camera rotate system. And let's double click it to open up in Visual Studio. Let's add using Unity Engine a statement, and after the I execute system, I initialize system. Again, let's store only the game context here. Game context. Let's retrieve it here, and let's make this one private read only. We don't want to change it. And let's create a new one, private read only, input context. To retrieve the mouse, if I can type, the mouse and the gamepad movement for the camera. Let's retrieve our settings config, let's store the transform of the camera and the transform of the pivot. And for our rotation logic, we are going to need several flow variables. So look angle, pivot angle, those are basically the threshold or the range of the yaw and pitch of the camera. So here in the constructor we also need again the transform of the camera, so the camera transform and a transform from the pivot, so the camera pivot transform, and let's assign them to their corresponding variables. So camera transform, the camera transform, and camera pivot transform, the camera pivot transform. Let's also retrieve the input context from the shared context we are passing here, input, and also the settings. Settings. That's it. Again, we need to honor the initialize system by create a public void initialize method, and from here we are going to retrieve from the settings file our minimum pivot angle. So let's do a settings context, game settings, value to retrieve the scriptable object, camera config, and minimum pivot angle. Let's do the same for the maximum. So in this case is the maximum pivot angle. Let's now replace the camera look speed and camera pivot speed from the game context with the values from the settings file again. So game context, replace camera look speed. Let's just copy this part here, and then we get the camera look speed, and we want to do the same for the pivot speed. So camera pivot speed, there we go. Now let's add the logic. This again is going to be applied only if we have a local player to work with, and let's retrieve our input as a vector 2 So access value, input context, look input, value, and let's store in the look angle variable we created before. So look angle is going to be equal to look angle plus access value dot x times our game context camera look speed value, which is the float from the component, remember. We want to do the same for the pivot angle. So pivot angle, in this case minus axis value y times game context camera pivot speed value. And we want to clamp this pivot angle by the minimum and the maximum threshold we have above. So let's create a pivot angle, mathf clamp pivot angle. We want to clamp it by the minimum and the maximum. Now let's create our vector tree for the rotation. So the rotation we don't care about, we set the rotation y to our look angle variable that we set here. And for the rotation we actually need a quaternion, so target rotation is going to be quaternion Euler, and we pass our vector tree, and we change the camera transform rotation to this new target rotation. After doing that, we need to reset this rotation to add to the rotation X our pivot angle now. And let's change the target rotation to a quaternion Euler rotation, and change the camera pivot transform local rotation in this case to our target rotation. Simple as that. So let's close the script, minimize Visual Studio, let Unity compile, and we need to add this new system to our Bootstrap system script. So let's do that now. Let's jump into the mono behaviors. We have the Sandbox system here. So let's open up in Visual Studio. And since we already have this late fix update system, we only need to add our new camera rotation system here. So let's just copy this first one and change it to camera rotate system, we need to pass the context, the camera root, but also we need the camera pivot. There we go. In the start we are already initializing this new system, and in the fixed update is already running. So basically we are good to test. So let's let me close this script and let Unity compile this new script, and let's jump into, we are already in the Bootstrap, so let's just hit play. So let's hit play and let's test this out. And right away you can see that we have camera yaw and pitch rotation, and if we start moving the player, the camera start follows. So everything is working as expected. So let's make a build to try this out in multiplayer. Okay, so it already compiled or create a build, so let's open one instance, let's move it here, and let's open up another one, let's move it over here, let's start this one, and everything seems to be working as expected. Player is moving towards the direction of we are facing with the camera. And now let's create another or join this session. So we have a reference now, and as you can see, it's working as expected. Thank you for watching, and on the next video we are going to start creating the animation system to hook up the walking and running, and later on we'll continue with adding the player plates names on their heads and so on. Thank you for watching.